Let's see, streaming. Good day, folks. I hope this is working. Just doing a live here, and I want to talk about dielectric resonance. So I'm just going to wait a little bit and do the general intro here and see if some people log in. If not, of course, they could watch the video later. And I don't like the angle of that camera right now, so I'm going to try and move that without screwing anything up because I have to look up continuously here. It's set way too high. Is that okay? I guess that's better. At least I'm not bothering anyone. No one's logged in yet. I think it's working. Check, check, 1, 2. Okay. So just gonna put this away. Yeah, it's working. I can see myself in the studio. All right. So I hope everyone is doing okay tonight. Um, I've been pretty busy with some experiments myself and some research and of course, every time I start experimenting with this one wire stuff, there's always these things that happen, and I always keep like losing parts and blowing things up, which reminds me why I gave it up 6 months ago. So, yeah, with that said, I did a pretty excellent demonstration yesterday about the one wire system, how you can use essentially a 12-volt battery that kind of acts like an ion valve, and whatever you put on the other side, it doesn't affect the main. Anyways, if you want to see that, I have it in my last video where it basically doesn't touch the reactive load that way. And the problem with that, I was using a rodent type of coil, which generates a lot of scalar waves for those who follow this kind of thing. And I've been building my PEG power cells. So I've had like maybe, I'm just going to say real quick, 10 different variants running different things from LEDs, watches, calculators, whatever, just to say there's always a load on them so I could observe, some of them are in my bedroom, some of them is over here. So anyways, scattered a little bit all around the apartment. And without thinking about it, I'm recording these demonstrations for yesterday's video, showing how well it's working. And this is what led me to talk about dielectrics, by the way, for this video, because it's relevant with the PEG cells because the PEG is a very reactive dielectric, which is also a low temperature version of an electret as well. So very interesting material properties with the PEG on its own, but I wasn't really thinking of that when I was showing this demonstration. So sure enough, especially the one cell where I have it as a plate and it's running a clock module. And typically, about 1.5 volts, few milliamps. And of course, if people have been following me, they know that these cells produce transient AC spikes all along. And on my scope anyways, I measured up to 200 microvolts of fluctuations, positive and negatives. Not all others have replicated it and noticed the same thing, by the way, so it's not just a me effect. And I even tried isolating it with capacitors between two cells, and naturally capacitors will block DC, right? But they will allow AC to pass. So I was still getting, energy loops going, so that's in another video. But anyways, what was going on with that is I'm showing this video from last night, and this thing is, but I wasn't focused on the scalar waves. It's just a byproduct of the configuration of the coil I was using. And people keep correcting me. It's a star-shaped coil. Yeah, no, it's a rodent variant. Just look it up on YouTube. There's a whole bunch of technical specifications, but whatever, if you want to call it a starship, call it a starship. But anyways, um, it has scalar properties that I wasn't really highlighted on for this specific experiment. It's just what I had around that I wanted to use basically to build a crude nonlinear asymmetrical capacitor with the one wire, essentially capacitive coupling. And essentially this was putting out a scalar field. So usually when I've experimented with, especially with a few milliamps of drive, right? The scalar field is, a few inches, and it still dissipates as you get away with distance. So here I am, you're showing all these with the going around with the fluorescent lamp on the battery and showing my demonstration. Meanwhile, this thing is saturating the room with scalar waves. Not only the room, by the way, but the whole apartment, okay, was saturated with these scalar waves, driven with a few milliamps in this starship coil. And what was happening is my peg cells, which I didn't know was a feature until late last night after I made the video, the peg material as a dielectric is very, very reactive to scalar fields. So in other words, the scalar field had no problems penetrating the plates and charging the dielectric directly, and everything I had connected to my peg cells surged last night during that experiment, unfortunately. Even the ones that were in another room, which is quite remarkable because we're talking about distances of 25 to 50 feet here, okay? So here I am trying to figure this out. So with the help, of course, of ChatGPT, I ask it, a typical watch module, 1.5 volts. Sure enough, it tells me, a milliamp or so will run those, which is pretty well nominal of these peg cells in regular circumstances. But I said, okay, for it to actually surge my watch module and the display just goes black all over, how much of a surge would I have needed? So it starts calculating and blah, 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 and it goes, well, about 4 volts at 100 mA would do it. So it's like, okay, so give or take, these peg cells were transducing surges of around 4 volts, 100 milliamps in another room. So just to give you an idea, which is really weird because I had ham radios, and I was in an earlier, like months ago, while I was trying to test the response of the peg cell on the scope, and I was feeding like 5 watts of RF energy, not scalar wave, just regular traditional RF transverse waves. They weren't nudging, so I figured, well, I guess they don't react to those kind of fields anyways. But when it became scalar, it was a whole different story. And I only found that out late last night, so I thought I'd put it out there to share with everyone. So just reading the comments here, so just bear with me. The peg cell electrolyte is just Restorlax is what I use, the brand. I've heard that people have tried using different brands and they don't get the mixture right. It either dries into a powder or like you said, it stays partially wet and there's a high measurable resistance. Mine, even there's always going to be a very high resistance, but normal meters, if it's working well, shouldn't be able to measure it. So that's the thing with that. And the voltage should be pretty high. Like any good working cell should give you over 1 volt. So unfortunately, I don't know what's up with that because people show me the ingredients and it's the same, but it's another brand, but it doesn't harden the same way mine does. So Restorlax is the one that I use. And an alternative solution maybe with the other stuff, because maybe the composition, just don't add water, just heat it up in a light heat over a stove top until it'll melt into a paste. And while it's hot, just pour it in its molten state and then let it dry out like that. Some people I read in some forums have been successful with other brands doing it that way. So just something to think about if that's what you're trying to do here. Scalar waves, I'm talking about the quote-unquote special field that shows up when you do the canceling effect, 180 degree between frequencies or coils. Tesla's longitudinal waves, essentially, is what I mean, if that makes any sense. Yeah, unfortunately, brands seem to matter from people's comments with the peg stuff. So anyways, I was talking about what happened last night, and that got me thinking. So I started doing some research here on basically top dielectrics. I wanted to find out, basically the dielectric constant and what applications they're used for. So I basically made a chart here of the top 50 candidates. And some of these are pretty interesting. And by the way, we could use these. Some of them are compatible as solid state electrolytes as well. So applicable for power sensors as well as capacitors. And I just thought, I'd share some of this with you. And when I'm done, I'm going to have all of this information, basically the transcript, available as a PDF for download on my forum as a link. But I'd like to share some of this with you for now. Like the number one on pardon me if I can't even pronounce some of these, by the way. I'm going to try my best. But number one at the list is calcium copper titanate. Calcium copper titanate. Being crystal based, it could probably be used as a solid state electrolyte as well. And it's got a crazy dielectric constant of essentially, if my eyes are reading that right, that would be 10,000. 10,000. So super high capacitors. And the next one in line would be barium strontium titanate with a dielectric constant of 8,000. So a significant drop here, folks, and that's number two on the list. Still good for capacitors. And then, of course, I'm sure we could all guess number three. We talk about it very often. So that would be barium titanate, John's favorite, essentially, John Hutchison. And that dielectric constant is 6,000. So a significant drop and still very high, right? So underneath that we have, I don't even know if I can pronounce that. Oh boy. Lead zirconate titanate at 5,000. And then the next one, lead zirconate, oh my goodness, 3,500. And it goes on. And a few interesting ones on the list. A lot of barium variants essentially keep coming up. But we have a hard time getting barium, so I'm not too much of a fan of that one personally, folks, if you know what I mean. So I'm trying to, lead is a good one. Copper and calcium, and it's essentially number one on the list. It might be a catch. I haven't checked this all yet, but there must be a catch because calcium copper titanate at 10,000 is amazing, and it beats barium titanate. So imagine building power cells with that instead of barium titanate. Major gain factor here. So very, very, very interesting stuff. And another good one that comes up, potassium is one. Potassium niobate, that's said right, at 450. And of course, the one I've been talking about is a good one too, bismuth titanate. It's at 200, but it's still good because it has a unique feature that it's very resistant to super high temperatures. So if we're looking for very, very high voltage interactions, the bismuth titanate is a good choice for dielectric. So going down the list here for more interesting candidates. And of course, I'm going to post all of this after because it's very good information. It's just I'd be here for 6 hours if I would go like line by line here. Oh, here's a good one. Germanium, typically used for diodes, which makes me think because, you know, we know about the Swedish stone, right? So we use diodes, but the diode doesn't always have to be a diode, is what I'm getting at. So even though we use it for that, it could be used as a dielectric as well. And has all kinds of unique properties, especially nonlinear properties. So there's a pretty interesting one right there. Lead again, lead magnesium, silicone, but we already know that one. Magnesium oxide, believe it or not, is another viable candidate. Calcium carbonate, mica, we know that already, that's pretty generic. Oh, epoxy resin could also be used to build electrodes. Nylon, pretty easy to get. Teflon, pretty easy to get. So basically it goes on and on. And what I'm looking for is materials with special properties and enhanced field couplings, because it's okay to have a list of the top 50, but depending on the application, it may not be applicable for what specifically I wanted or what we want to do with it, right? So the list goes down quite drastically when you're looking for specific special material properties. So of course, then the first one on the list becomes barium titanate because it's ferroelectric, it's highly piezoelectric, it's good for capacitors and sensors, of course. Second one on the list, lead, sorry about that, lead zirconate titanate, again, piezoelectric and ferroelectric. Lithium niobate, I hope I'm saying that right. It's high temperature resistance and ferroelectric. Lead magnesium niobate, ferroelectric, dielectric, high permittivity, also used in capacitors and sensors. Strontium titanate, dielectric electro-optics. So this could be used for nonlinear field interactions as well. What specific properties I'm looking for? Anything that can help with field couplings. I'm not there yet, but the next thing I want to talk about is dielectric resonance. So, but for that, I'm looking for specific materials that would help with its own natural properties, you know. So, that's essentially it. What I'm looking for basically piezoelectric materials, ferroelectric materials, magnostrictive properties, that sort of thing. The lists, my own research, I generated it with a table and help of ChatGPT, and I put it in order basically. I'm going to have all of this available, by the way, as a PDF. I'm just highlighting the strong points here because there's a lot of research here and there's a lot of candidates, but like I said, this is an Excel chart I made myself actually. So yeah, some of it is my own. Uh, let's see here. So essentially, I started to think, right? So instead of charging up capacitors to the electrical plates, we could also charge capacitors through direct dielectric resonance as well, through the pure molecular vibrational natural frequency of the dielectric. Depending on the application, that could be a much more efficient method of generating an electric motive force across a conductor, essentially. So this led me to try and calculate the resonant frequency of specific dielectrics. So I did a calculation for barium titanate, and also I did one for bismuth titanate. So interestingly, you could make simple dielectric resonators with simple radius and height dimensions. That's like one of the most simple way of getting into it. And what's very interesting, and this actually revealed to me in part why John Hutchison was getting very good with his barium titanate cells. And I'll get to that in a moment. But what's happening here is, let's say we have a radius of 10 millimeters and a height of 10 millimeter. For bismuth titanate, and I have the calculations here, and I'll show you all this in the PDF later on. So essentially, when you do the calculation with these dimensions, for bismuth titanate, this is very good because it resonates at 1.14 gigahertz, which is the microwave band. Now, if you want to tune it, you just need to increase the dimension and you'll lower the frequency. So this is very simple to tune. Now, which becomes very interesting, folks, the same calculations for barium titanate, which is what John Hutchison used, at these dimensions go down to 211 megahertz. So you increase the dimensions, if you just visually from what John Hutchison had, from his plates, and you do the crude calculations here, his cells were basically resonant in the middle of the FM broadcast band, which you have thousands, even megawatts of wireless RF energy focus within, a city block radius. So the fact that his cells were generating a few watts would suddenly make sense once you make this calculation. Not saying that it was a fraud or anything. Very clever what he did. He took advantage of basically a very, very good system to couple into these external fields to boost his electrostatic potential that he already had established within the cell. So, however, I don't know if he never noticed that or talked about this. If he would have varied the dimensions at all from what he had working, it would not do anything like it were doing. So if he tried to make smaller versions like half size, they wouldn't work at all. If he tried making double sizes, they wouldn't work at all. They Maybe that confused the gibberdees out of him because it didn't make logical sense of I could just scale up what I have times 2 and it should work, right? Well, in the case of pure dielectric resonance, that would have screwed up his resonant frequency, and all of a sudden he would have been resonant with maybe 10 megahertz. There's no significant energy down there to drive it, even though it would have been physically double the size. You see what I'm getting at, folks? John, in a way, fluked it right into the center of where all the megawatts of RF energy happens to be. So, you know, perfect for that. The cells generate a baseline electrostatic potential and then they charge up as a capacitor through the external fields. So that's what was happening with John's cells. He was getting voltage, current was being extracted externally from external fields, which happened to be the FM broadcast band, by the way. So think 100 megahertz would, let's say if you're in a city, so all of the towers are concentrated within a few miles. So the field strength concentration, when you add all that up, when you know you have one station 100.1, another station 100.9, another station, you know, it's a lot of focused concentrated megawatt energy. Usually, and what I'm getting at is it's not something a simple antenna could normally get into. So it's not as simple as setting up a 27-inch, which is basically the quarter wave of FM broadcast, putting a capacitor on there and getting tons of watts for free, because everybody would be doing that, right? Because it wasn't an electric tap, it was the dielectric equivalence. And then it was his conductors in the cells that tapped into that energy through the pure molecular interaction, the vibration of the dielectric through the FM broadcast band. That's what was going on here. So it's not typical, it's not like energy harvesting where you're setting up an antenna, an electrical version. John was doing it through essentially doing it backwards, charging the dielectric directly through an external field at its. The only way you can do this is it has to be at the resonant frequency, because what happens is, you see, RF is AC, right? And you're going to say, wait a minute, a capacitor cannot charge with AC. All it can do is displace the AC current from one place to another, essentially. So the reason the dielectric resonance molecularly creates a condition, basically a nonlinear. So it's a memory effect that after a while, the dielectric will retain a memory. And it's that memory that sets up the potential difference between the electric plates. And then if you want to go it further, the actual breakdown of the dielectric itself sets up the potential difference. So it's not a traditional system, but it's still triggered. It's very interesting, actually. Very, very interesting stuff. So, so basically dielectric resonance, it's the non-electrical equivalent of a tune system. But instead of you electrically, it's the molecular vibration at resonance. And when you set up that condition, it allows for the dielectric, even with AC, to establish that potential difference. So that's why essentially it can charge with AC or external fields, where in normal circumstances, it wouldn't do that. So what happens is, folks, you can't just take an off-the-shelf capacitor and expose it to FM broadcast and it's going to be an energy harvester. It doesn't work that way because the dielectric has to be specific. It's a vibrational effect. So this is what happens here. Very interesting. I don't even know if John realizes what he had going. But I understand he had some help from Tom Biernan and a few others, high profiles in the field, that kicked him in the right direction. Perhaps they know, but they wanted to keep it, low key. Now, my issue with John's cells is maybe the reason it never took off financially is exactly that. Internally, there may have been studies and they found out it's a great energy harvester in that sense, but if we want to use this technology to essentially power rockets in space, there's no FM radio up in space, folks. The cell will be a regular good as it is, an electrostatic cell. It might not be what they were intending for, you see. So what I'm getting at is John's cell might only work the way it worked in his videos in urban dense environments, which I'm not criticizing. It's very clever, very clever. I mean, one could take advantage of that, tune it to a frequency that you're locally generating to create a non-electrical feedback loop, you see, without breaking the laws of physics. It really gets one to think. It really does. Yes, I have talked to John a few times about this, but he's great. He answers my emails, but he doesn't get into any technicals. Just, great, good job. You're on the right track. I love it. He sometimes says he learns things from me, which is great. But he has actually shared very little technicalities with me personally. And I don't mind either, I mean, I don't want to sound like a pest with him either. So, but if I tell him all this, and I give him all the math, I don't want to insult him either. And I'm not doing it as an insult. I love it. I think it's clever. But, he may take it the wrong way. And I don't need that, he's a nice person, supports my videos, comments once in a while. So I don't want to be a debunker, That wasn't the intent of it all. I'm so focused at figuring out how everything works, Yeah, there's the open source thing, there's a lot of an ego. Even if there's no money, I don't know if you've noticed that a lot of people, even on YouTube, if it's not just for the following, um, they I don't know, it's like, I talked to this guy that I can't say, who's been in this for 25 years, who's given me the information for a blah, 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 and I'm going to only share this much with you all. I feel that that's a bit of a repeat theme throughout YouTube. Not everyone, but um, when it gets to like trying to put a wall behind the information and trying to indirectly, not take responsibility for trying to cover up the information, essentially, is what I'm trying to say. They don't want to sound like they're being the ego, but they need to make something to make it sound like, folks, it's not us, it's not me. If I had my way, I'd tell you everything, but and some people, they think, their life is in danger, or some national security that, maybe a tiny little bit in John Bedini's day, but that's over. Even Tom Bearden knew that those paranoid days were gone. But yeah, I think they may be in fear, but what I'm getting at is I think they use the fear to try and use it as a captivator to motivate people to be like more into their content. But at a certain point, I think it gets boring when you follow someone for a few years and they don't at the end of the day give you any meaningful information. But I'm not the one to judge, right? Some people they want to be entertaining, and it's the entertainment value, and that's why people watch. You know, I'm focused more on providing information, but there's no set rule that says everybody's got to go on YouTube and provide pure information. If people want to be entertaining, they want to be suspenseful, they want to be mystery, they want to captivate their audience like that, nothing stops them to do that. And if there's a business model behind it and that can monetize them, that's power to them. I may not agree with the business model perspective of it, but they're not doing anything wrong. And that's the thing. A lot of people use this theme of alternative energy to as a kind of prop up, you know, to make a kind of image with it. Yeah, I didn't want to say electro boom, but essentially somebody beat me to it. But exactly that, right? But at the end of the day, he has his right to be on there, and it's obviously a business. If you see at the subscribers, so the guy monetizes, he pays to advertise his feed and the recommendations. That's how it got to that much, because no one, would naturally go there for it to have come, that high up. But if he pays to advertise it, it gets the generic clickbait people who just like waste 15 minutes of. But again, some people, the people who are there are into it. So you can go bad people, they like it. So, you know, it's entertainment. But I'm not entertainment. So I clash with these kind of people. There's a big conflict. They want to make money, they want to monetize, they want to stretch it out, they want to keep the people watching for as long as they can because that's how they make their revenues. So as long as they could keep it funny, captivating, entertaining, that's what brings the viewer. But I'm not doing it for any personal gain. So whether I started at a few, a couple people, which grew to a couple hundred, even when I was at 500, and didn't matter to me the information I shared then versus what I share now. The same way as it doesn't matter now that I have 3,000 as it would if I'd have 10 later on. I don't benefit. We all benefit from it. And it's my motive, it's my hobby, it's my passion. I like, and I've noticed there's not that many. I wouldn't say I'm not the only one. I've personally met a few really good people. We've talked regularly that essentially do in their own ways the same thing, and they share what they can. So there are people, but we're all hidden away, um, unless people search for it. So it's not like totally hidden away. We have a group of people, but we're not going to change the world anytime soon. We're no, what I'm getting at is we're nowhere near the social influencer level yet. Maybe one day, all of us together, maybe adding them all in. But at least we're a group, and it's getting out there. People are talking, so that's good. And I like it when I see people replicating my concept. And then you search on Google the peg cell or whatever, and it's other people and they're happy with it. Especially when I was doing capnum circuits and hydrogen project, and I don't remember the person's nickname, but one person went completely all out on it, built his own fuel cells and the reactive power supply for it, and the thing was bubbling like crazy. And I'm like, holy moly, was really happy with it, you know? That's what I like seeing is to see people take the concepts, the information that's worth a lot, and do those things that maybe I can't do because I don't have a garage, I don't have a torch, I don't have that sort of stuff. But someone that understands, who has the engineering skills, can the handwork, can do it. And everyone so far has been very happy with what they've been able to replicate. One day I hope to get there because I like to be able to show something for myself that essentially would equal to commercial quality power. And that's when you really get noticed, like Gerald Morin when he did it, right? Next thing you know, you got 60,000 people following you. That would be nice. Again, not for personal gains, but just for having it all out there, right? That would really, could have a talk show that in those with those numbers. Someone is asking about frequency of magnetic fields. I thought that was what Floyd was after. He was designing transformers very efficiently. He knew about these anomalies to take advantage of them. The ancient method, yes, yes, I will. I just, ay, ay, ay. It's because I know I'm going to, you know, I'll tell you what it is with that one. A lot of people are going to make fun of me for it. And I'm not looking forward to all the trolling. They're going to flat out, I know what is going to happen. And yeah, it's a lot of information, but people are going to scrutinize me for it, I know. But I'm trying to gather all the information in the most coherent presentation so that I can minimize all that. But I'm a little worried about it. Thing is, I've talked to, friends and private, business investors and paralegals and things like that, and prosecutors, and uh, it's stepping into I'm actually a little worried, and I don't want to screw myself over either with this one here. It's nothing bad or anything, it's just either it's going to get buried in all the trolling or someone's going to take off with it, and um, what I hate is what something is really good and no one gets the proper credit for it. I don't care what people do, but at least say they where they got the idea from, so other people can find the open source. You know what I'm saying? And then find the full picture. Someone takes credit for it and goes, no, 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 can't tell you what it is. People don't know any better and they could develop it themselves. That's what I don't like, personally, is when somebody does that. Tries to close source something that's open and then takes credit for it. Ugh. It grinds my gears, as they would say. Worried about uh, I know I always say don't want to commercialize, but one day in my life I'd like to get out of this hellhole. If I could only commercialize one thing out of a million, so I could at least afford to not have to live in an igloo for the rest of my life. So that's essentially it. You know, some people have told me, especially in the business, that I've got something here, and that I'd be completely stupid as a business person to actually open source it. That's what I'm getting at. And it's not like me. But getting older and realizing that nobody's really helping me out here at the end, which I don't expect them to. I'm not getting a garage, I'm not getting a lab. It's not like I have an inheritance plan or anything like that. That sometimes, folks, just sometimes, you know, a person has to think of themselves. And it's not to be selfish or anything, it's just, I don't know. I'll get back to you all in a few days on it, anyways. That's what I'm getting at. I'm going like through a middle age crisis, I think. If you know what I mean. It's not fame. It's, like I said, it's the commercial value that I could have to get out of this situation I'm in, essentially. Which I'm probably end up going to die the way this way. But like I said, if there's just one thing, you know, it makes you think I'm just a human being like everyone else, right? But like I said, I've got some thinking to do, and I'll probably get over it within the few days. And um, I want to talk about it one way or another. It's just I'm not sure when I'm willing to put the complete picture. But like I said, I don't want to deceive either. You know, I don't want to give out half of an idea and not have the other half, and that's what actually triggers trolling, because if people don't have the complete picture, then they just assume, sorry for the language, you're flat out bullshitting them. So what am I gonna do? What am I gonna do? You know, if I had a bit more of a reach out, you know, get some sort of a financial backing for kits or something, I wanted to do that before, you know, maybe not make money, but have enough to support something. I don't want to go on Patreon. Turns me right off, and the people on there, 99% scams. I see that and I get mad. You know, people living in mansion doing crafts and landscaping, and they ask for Patreon donations, and they basically live in the freaking castle. Are you kidding me? I just, but it's playing the game, you know? And I'm not good at playing the game. I'm not. So I think maybe just keep doing what I'm doing, and be happy with the one or two subscribers extra I get a day. That's essentially what it is. But like I said, I will, folks. I will get into it. I'm just having a middle age crisis here. I'll get over it within a week or so. No, that's the problem. I don't have the resources to do what I want to do, and I'm actually getting a bit. I don't talk about this, but it's I'm getting depressed with it. Some days I feel like just putting all of this on hold for a few years, or focus back on radio broadcasting for a while, because theory is one thing. I demonstrate prototype concepts, but again, at the end of the day, everyone is after commercial quality power. I cannot give anyone that unless I have a lab. And yet, you know, you like John, you can't guarantee any of this unless you try it. I'd like to try it one day, but you know, no money, no funny. And no one who's smart anyways is going to invest into something where they don't expect any return. You'd be stupid business-wise. You may as well burn the money, right? You know, who's going to do that? So I understand everything, and I don't take it against the world. So you got to do what you can with what you got. But you know, some days it's like, ugh, if I could just buy an underground bunker or something, have a lab in there and win a couple $1 billion and have staff and I tell them what I want them to do for me. See, that's what I mean, folks, about trolling and everything, right? So I haven't even released the information I want to release yet, and there's already people who are not happy with it. So it's pretty funny. So as I said, I fully expected it, and will just do what I always do. But not to say that I didn't warn you folks, there's going to be a lot of trolling. This is a good one. One unit could generate maybe 10 watts. And like one person said, you can stack them up. The only problem I have right now is I estimate that one unit will cost about 200, and that's best case scenario. It's $240 to build. Now the problem with that is if we were going to say, let's say it lasts 3 years, well, $240 for 10 watts continuous for 3 years, you're actually $100 in the red if you were to pay the mains for it. Average, just ballpark figures here. But that's not the point, right? The point is the off-grid application, right? And of course, you have to take into consideration that's my cost if I just buy a jug of various chemicals to do it. You see, if I were a manufacturing plant, everything becomes wholesale. So instead of costing me $240 to build one, I may be able to reduce that to about $6 or so if they're being mass produced. Then it's worth it. So, you have to, it's all in perspective and fine balance. GoFundMe, yeah, I actually had a GoFundMe for a while, but I wasn't using it enough. And I think they actually disabled my account, I think because I wasn't getting any donations on there. Um, I actually tried locally with the Hammer back when they were still alive. I used to give out the links because I was treasurer. I was part of the ham radio club for many years in Timmins. So I did a lot of interacting that way. So yeah, I don't know about GoFundMe because I heard a lot of Canadians if you don't follow their narrative, they don't give you the money. Plus, I have issues with the funding and everything, so essentially I have to set everything up in a trust, which is fine. It just complicates things for research. Yeah, Bitcoin works too. There's a few ways of, but again, the problem is I don't like asking because at the end of the day, someone always has an expectation, and I don't want to disappoint. I want to know for myself. So if I'm the one who wastes $200 of my money to find out just because I was curious, it was entertaining, it was a learning curve, I learned a lot in the process, then to me, that $200, let's say, was worth it. But let's say someone, let's just throw this out there, decides to put $20,000 in my name, do what you want with it. They'd be pretty pissed if there's nothing in return, right? I mean, it's just common sense. So I would not expect it. I don't think of it either. but you know, you can still like dream in color, as they say. No, I don't. I'm not there yet for the 10-watt thing, the ancient device. I have it already. I just have to get to my whiteboard and do the presentation. And like I said, I've been battling with myself whether or not I really want to, because a few people locally have seen it, and they really think there's a commercial aspect to it for patenting and everything. And like I said, again, it's just that one thing out of a billion, right? That could maybe secure my future. But essentially, no, you know, I do want to keep everything open. And you know why? Because even patents get scrutinized at the end. And there's a lot of people who will even claim a lot of patents are bogus and they won't even work. So if somebody stigmatizes the, let's say, category of what the patent represents, the patent may be junk anyways. So I have to look at that perspective as well, because, for example, have you ever seen any flying saucer patent lately get bought out? No, because common sense, right? The patent says it works, but no one actually flew to another galaxy with it yet, you know? So therefore, there's no business interest, there's no commercial business deals being made to buy all the rights so Sony can build flying saucers, you know? So yeah, it's good to have a patent, but sometimes the patent can be completely useless if it's stigmatized or the investors have no clue what they're looking at. I'm just reading the comments here. So oh my goodness, I've been talking and talking. I usually say hello to everyone, and I didn't even do that. I just got right into it here. It's amazing. I can't believe it. We had actually 75 views at some point tonight here. Um, I think what's happening is I think I'm more comfortable on the sofa because usually I stand up, and after about half an hour there, ooh, you know, it starts getting but in this environment, basically in my living room, it's just like instead of watching boring news TV, it's just like sitting out here and chilling with everyone. And the time went by so quick, I can't believe it, actually. So with that said, of course, you know, I just wanted to talk about that and dielectric charging so we can charge the dielectric directly instead of doing it through electric plates. And there's something there for sure. John Hutchinson knew that with his crystal cells. Not sure if he was aware that the target frequency was actually the middle of the FM broadcast band. That was new to me tonight, and explains a lot when you've got like megawatt power in the middle, and that's what's exciting your device, right? So pretty cool. And like I said, I've got some information of what we've talked about here tonight. So just give me maybe a moment to upload that. I will post a link, most likely to my form, with all of this information. So it's really good information. I called it, it's a top dielectrics chart with all of the elements that you can use, top 50 of them, for those who want to work with this kind of stuff. And with that said, I think I will wrap it up for tonight. Yes, the radius and height calculations are in there as well in the PDF. And I actually made a Python program that I could just enter the values, any dielectric, and the dimensions and the radius, and it gives me the frequency. So it's really easy for me to figure target frequencies, right? So like what am I aiming for? Of course, a potential self-loop system. But instead of looping through pure electrical, we could take advantage of the dielectric resonance as well. And if we build crystal cells, well, we have the electrostatic potential that sets it up. So, take advantage of a few interactions here, and something could be pretty interesting. And like I said, I will post I think the easiest thing is to just post the PDF as a link in the video comment, because once I kill the stream, I believe I can edit the description. And in the video description, I shall have a link to the PDF. So with that said, folks, again, thank you all for sharing your time here tonight. And of course, looking forward to your off video comments and suggestions and anything else you'd like to talk about. And until next time, folks, and thank you again all for your support.